Hello everyone and good afternoon to all of you. Today we have problem which name is determined if a cell is reachable at a given time. Leetcode 2849 problem. So before going forward in this video, please make sure that you have liked and subscribed to this channel. And as I always say that it's my advice to all of you that please read the problem statement carefully and try to build up the intuition in your mind and try to do the code. If you are beginner, then you will stuck at any point. You definitely will stuck, and it's not a big thing. Okay. Then whenever you will stuck, please see this video. Then you will understand what is the problem. Okay. So try to do the code. If you do not do the code and see the video, it will not be beneficial for you. So please read the problem and try to do the code. It will be beneficial. Okay. So let's read the problem. We have given four integers sx, sy, fx, fy, and a non-integer integer time t. In an infinite 2D grid, we are starting from the cell sx, sy, and each second, you must move to any of its adjacent cell. Means at each second, means at a given time, at each second, we have to move. Okay, we can't. Matlab means we can't stay at a certain point. We have to move. Okay, so we have to return true if you can reach cell x, fx, fy. These are my final points. Okay, after exactly seconds or false otherwise. A cell adjacent cells are eight cell. We know that we have eight directions, so we can move anywhere. Okay, so let's think about this problem. Let's build up the approach. So let's see. Yeah, if we have given this start pointer and end pointer, so we can at t equals to 1 second we can go. Yeah, we can easily go at t equals to 2 second we can go downwards, then we can go diagonally, then we can reach the point end pointer. Okay, we t equals to 3 second we can go downward, then right, then up, we can reach the point end. Okay, yeah. In example 2, let's see this. At t equals to 1 second, if we go diagonally, then we can reach at end pointer. Okay. If t equals to 2 second, we can go right and then down. We can go. Okay. At t equals to 3 second, we can go right. Then we can go left. Then diagonally. Then we can reach the end pointer. Okay. So let's see. Let's think. Is it always possible to reach the end pointer at a given time? No, it is not possible. Let's think 3 cross 3 matrix. We have a start pointer and end pointer at a given t equals to 1 second. T equals to 1 second, we can go right here, then here, then here. We can't reach the end pointer at t equals to 1 second. So it will be false. At t equals to 2 second, we can go at diagonally this, this, then it will take the time 2. Okay. So t equals to 2 second. And after 2 second, we can go. Okay, we can reach at the end pointer. So can you think at a certain point, at a point after that point, we can go. Okay, we can reach the end pointer. So at a certain point after that point, we can reach any pointer. We can reach any go. We can reach the end pointer. Okay. So let's think about what is that point. So let's think if we have given a square matrix. Okay, so the shortest path will be to, so the shortest path from the start to end pointer will be the diagonal path, because diagonal path is very short. As you can see, it will take the time 2 seconds, 1 and 2. In 3 cross 3 matrix, if you take that 4 cross 5 matrix, then always the diagonal path will be the shortest path. So we can see, if we find the that diagonal path like this, if a difference we have given the sxxy and fxfy, so we can find the x difference, x direction में कितना difference है, that is given by fx minus sx. Okay, absolute value, because it can be fx can be less than the sx, so we will take the absolute value. Okay, we will find the x difference and also y difference, and then we can check. it is a, if the given time is less than if the given time is greater than equals to the diagonal time, diagonal time, how much time it is taking to uh, go from the start to end. Okay, so if my given time is greater than equal to the minimum time, this is the minimum time from reaching from start to end, it is good. If this condition holds, then it is good. Otherwise we can't reach. We will return false. So it is in a square matrix, but it is not possible to have the square matrix at always. Okay, always it is not possible to have the square matrix. So we can have 3 cross 4 matrix and 2 cross 5 matrix also. Then we can find this. Okay, so let's take this matrix. It is not a square matrix as we can see, but we can create this as a square matrix. If my SX SY pointer is 2, 4, it will be the example of Leetcode. Okay, and the FX pointer is 7, 7, 7. So we can see the X difference will be 5 and the Y difference will be 3. So how we can find this? Sx minus Sy, Fx minus Sy, Sx 7 minus 2 5, X difference, and 7 minus 4 3, Y difference. Okay, this is done. So let's take a water. So now, as you can see, how we can find the square matrix. So minimum of X difference comma Y difference will give me the square matrix. So let's take the minimum. Minimum will be the 3, 3 comma 5. The minimum will be 3. So this is my square matrix. So as you can see, this is my square matrix. And square matrix, in square matrix, what is the shortest time? Diagonal path will be the short, will take the shortest time. So it will be 1 and 2 and 3. Okay. So now I am here. Now I am here. Now we can go forward linearly. Okay. 1 and 2. Now we are here. So we can reach start to end pointer by using the diagonal path and linear path. Okay. So how we can find that means square matrix, the minimum of X difference comma Y difference will give me the square matrix. Then I will go the linear path. Okay, this is my final approach. So this is the X difference. So I can write this Y difference plus X difference minus Y difference. Because why I am writing like this? Because minimum of X comma Y will be 3, which is equals to Y difference. So this is the Y difference. This is the 3 cross 3 now, and this is the X difference comma Y difference. So now what I will do, I have to find the minimum time. So diagonal time, how much means how much time it will take? It will take minimum of X difference comma Y difference. That will be 3, 1, 2, and 3. Okay, this is done. X difference comma Y difference. I am finding the minimum time. Okay, now I will go to linear. So linear, it will take this time. As you can see, this time it will take, it is X difference minus Y difference. So absolute value of X difference minus Y difference. Because why I'm taking absolute value? Because X difference can be lesser than the Y difference. That's why I'm taking the absolute value. That will give me the positive value. Okay, so this is my final approach. So finally, let's see. So finally मैं कर क्या रहा हूँ? I am finding the square matrix. In a square matrix, the diagonal path will be the shorter path. Okay. So in a square matrix, I am finding minimum of X difference comma Y difference. That will give me the square matrix. It means minimum shorter time. Okay. Then I will go to linear. So how we can go? Absolute value of X difference comma minus Y difference, because this will give me the linear time. So this is the final time. That is the minimum time. If my given time is greater than equals to me this minimum time, this is my minimum time now. Then it will be 2, because if my given time is 3 second, मान लो 3 second, and the minimum time for reaching the start pointer to end pointer is 2 seconds. So 2 is less than equals to 3. This is true. So we can mark it as true. Otherwise, we can mark it as false. But as you can see, We have some edge case. We have at each second we have to go anywhere because we can't stay at any point. Okay, if what about if my start and end pointer at the same location? Okay, at the same location, huh? So now what I will do? At t equals to 2 seconds, it is possible. I can go outward, then I can go end point one. At 3 seconds, I can go outward, then I can reach the end start pointer, then end pointer. So it is possible. What about t equals to 1 second? So t equals to 1 second. If I go outward, then I can't go out. I can't come at the end pointer. So that is the base case, means edge case. At t equals to 1 second, can you move? No, I can't move because if I move, then I will go to the outward location, means other location. So I can't reach the end pointer. So that is the my base case. I can't reach. Then I have to find the false. I have to return the false. So let's do the code so that we you can understand properly. Okay, let's open this. Yeah. So firstly, what I will do, I'll find the x difference and y difference. So how I can find this? So enter x diff equals to fx minus sx. So absolute value of fx minus sx, that will give me the x difference, and in same manner I can write y difference also. Absolute value of why I'm taking absolute value, because it will give me the positive value, because it is possible that fx can lesser than the sx, so therefore that in that case that value will be negative, so absolute value will be positive. Okay, that's why I'm writing like this, fy minus sy. Now I have x difference or y difference. Now I have some edge case, like edge case. What is my edge case? If x diff equals to 0 and y diff equals to 0 and at a certain time, what was that time? T equals to 1 side. If t equals to 1, agar if these conditions is following that our condition, then I can simply return false, because in that case I can't reach the end pointer, so we have to return false, and otherwise we have to return minimum of diagonal time. How much the diagonal time is taking? Okay, I can write this minimum of x diff comma y diff. Okay, plus the linear time. What will be the linear time? Absolute value of how much time it is taking? X difference minus y difference. So write like this. Okay, x difference minus y difference. Okay, is less than equals to t. Agar this is if this is the less than, if this is the my minimum time taken to reach from start pointer to end pointer. Okay, and this is my given time. Is this condition holds, then this will be true, otherwise this will be false. Let's run this code. As you can see, it is working perfect. Let's submit this. It is taking 0 millisecond and better than the 100% of C++ user. Why it is better than 100% of? Because we are not taking any space or any, or we are not taking any space, or we are not using, means this is a big O of one time solution. We are not using any loop or another things. Okay, this is a big O of one time and big O of one space. So this is a better solution, yeah. Or see, we can write this as also, if we write this like this, oh, maximum value of x diff comma y diff less than equals to t. Let's see what will happen. This will also work. Okay, it is working. Let us submit this. It is also working perfect. So why I am writing this now? This condition, accept that condition. That condition is also true, and this condition is also true. Now you will see, you will find why I am using this, why I am writing like this. Okay, this will you find. Okay, I will not tell you the approach. This is the best. If you see this, if you have this diagram, if you have this diagram, okay, then you can easily find this. Okay, otherwise you can't find this. So this is our complete code. If you find this, why I'm writing like this, then please comment. Okay, प्लीज कमेंट जरूर करना। अगर तुम्हें मिल जाए ये कि तुम्हें कैसे, मेरे को बताना कि why I'm writing like this. Okay, so this is our complete code. If you find this helpful, then please like it, share, and subscribe. And if you know other approaches, there can be many approaches. I'm using big O of time, big O of one, and you can use big O of n also. That is quite a bit means moderate solution, but good solution. So please like, share, and subscribe if you find this helpful. That now we will meet tomorrow.